Ethernet and InfiniBand are both networking technologies, but they differ in key aspects. Ethernet is the most widely used network technology, known for its scalability and flexibility, and it's commonly used in LAN and WAN environments, whereas InfiniBand, on the other hand, is designed specifically for high-performance computing (HPC), offering lower latency and higher throughput. So in this video, we will demonstrate Ethernet and InfiniBand connectivities and also propose a combination of both worlds with a hybrid connection. An AI network handles massive, complex tasks by connecting multiple compute and storage nodes into a single powerful cluster. It uses a specialized back-end network, that guy right here, with a high-capacity optics and cables to keep everything running smoothly. In AI data centers, there are two main networks, the front end and the back end. Okay, well, we have the front end right here and the back end right here. So what about them? The front end network connects the data center to the internet and the clients, as you see it right here. Whereas the back end, this guy right here, it links the GPUs together, storage and compute nodes using ultra-fast connections that can range between 100 gigs all the way to 800 gigabit per second to handle the huge data loads generated by AI. In the past, the backend network relied on proprietary technologies like InfiniBand or fiber channels, but with Rocky, the industry shifted to a unified high-performance Ethernet network. Ethernet's flexibility and scalability supports speed from 100 megabit per second up to the blazing 800 gigabit per second that we mentioned, making it very ideal for demanding AI applications that need this kind of bandwidth. Since we're talking about AI, speed is everything. Speed is actually what matters. AI tasks are super intensive and they need to be spread across multiple interconnected servers to keep things moving quickly. That's where InfiniBand is going to play a major role here. It's known for its ultra-high speed connectivity and incredibly fast bandwidth, which goes again up to 800 gigabit per second, which is not very different from Ethernet. However, this makes it perfect for connecting servers, storage, and compute nodes together, ensuring data flows smoothly without any bottlenecks. So how does it work? How does InfiniBand work? InfiniBand can handle, as you can see here, up to 64,000 different devices using a point-to-point input and output framework that keeps everything running efficiently. There are lots of features. The quality of service is supported with things like ECN and PFC. You can have reliable, lossless, self-managing fabric and full CPU overload and kernel bypass by moving towards GPUs and TPUs. Lots of features. But hey, we also need to talk about the different layers within InfiniBand. InfiniBand's architecture is divided into a bunch of layers, 5 layers to be accurate here, and let's just name them right here: the physical layer, the link layer, network transport, and the upper layer. What about them? Let's start from the bottom, the physical layer. This is your foundation. This is the foundation where cables and connectors and transceivers are there. And then comes the link layer. Okay, well, layer number 2, switching, point-to-point link operations and switching within a local subnet. The switches are right over here. The subnet manager assigns a 16-bit local ID, LID, to all the devices within a subnet. All packets sent within a subnet uses those LID for addressing. And then comes the network layer, where the routers are going to be expected. This is the end-to-end packet delivery using routing, and routers are going to be your superheroes in here. Let's not forget transport layer as well. Okay, what does it do? Ensures reliable data delivery and manages the communication channels. And the upper layers right here, where this is, where we expect the client applications to interact together. So when it comes to an InfiniBand system, it's made of several key components. So first of all, something which is called a CA that can be subdivided into 2 other categories. CA stands for channel adapter, but it comes in 2 flavors: the host channel adapter, HCA, which is this guy right here, and the TCA, or the target channel adapter, that guy right here. So what's the difference between the two? These are actually, let's start with the HCA. The HCA connects the servers or storage devices to the InfiniBand network, HCA right here. Whereas the TCA typically found in embedded systems like storage devices, that guy right there. And that, let's not forget the switches. Okay, switches are going to be everywhere. These are the, they function similarly to the regular network switches, but are designed to handle InfiniBand's high performance needs. And the routers are here as well. Okay, so they're responsible for forwarding packets between the subnets, just like the regular routers. You can, enable the inter-subnet communication while providing subnet isolation with those devices. And let's not forget the InfiniBand cables, the InfiniBand links right here. And as we all know, there are the copper cables or the fiber optics and the connectors, which are used to link the various components together. What about a hybrid connectivity? The best of both worlds for an AI data center. Okay, hybrid connectivity means combining different network types like InfiniBand and Ethernet to create a powerful, flexible data center setup. In AI and machine learning environments, these technologies team up to get the best performance and cost efficiency at the very same time. InfiniBand, the speedster, used for super fast, there we go, InfiniBand right here. Used for what? Used for super fast connections between GPUs and TPUs during intensive model training. Whereas Ethernet, on the other hand, that guy right here, Ethernet, reliable workhorse, perfect for general connectivity, storage, and cost effectiveness, and all kind of communication. So why go hybrid? This is the golden question. It's all about optimizing performance while saving money. Use InfiniBand for demanding tasks and Ethernet for everything else. This setup allows you to scale each network independently, reducing cost and boosting return of investment. And let's not forget, there's going to be some kind of special devices here, like special gateways and bridges, special gateways mainly, that make these networks talk to each other, enabling smooth data flow between different systems. And for compatibility, I'm losing my words here. For compatibility, IP over InfiniBand, let's just write it down, IP over InfiniBand, IPOIB, lets the standard IP traffic run on an InfiniBand network. So let's summarize really quick. We talked about Ethernet as a connectivity option and why this is one of the most flexible options when it comes to building your AI-enabled data center. But on the other hand, let's not forget about InfiniBand and its low latency that can also be super efficient when you need to build those AI-enabled data center. And if you want to get the best of both the worlds, then a hybrid connectivity is also doable. I hope that this was informative, and I'd like to thank you for viewing.